Hi everyone, I hope you're okay. This is the eighth question, guys, whereby I'm answering the past exam question papers with regards to momentum and impulse. Please note that, guys, the other videos are already uploaded. If you click the link on the description below, you'll find a playlist whereby I answer all the 11 questions with regards to momentum and impulse. And the other playlist, guys, is for those who want to learn momentum and impulse from scratch. So please do choose wisely. You know where you are with regards to your level of knowledge in momentum and impulse. So yeah, just indulge yourself, guys. Before I even start here, guys, please don't forget to share the video to your peers. A thing or two that will be mentioned here might help them. Excuse me. Another thing, don't forget to like, comment, and most importantly, guys, don't forget to subscribe in order to help us grow the channel. Okay, a trolley of mass 1.5 kilograms is held stationary at point A at the top of a frictionless track. When the 1.5 kg trolley is released, it moves down the track. It passes point P at the bottom of the incline and collides with the stationary 2 kg trolley at point B. Refer to the diagram below. Ignore air resistance and rotational effects. Okay. In this track, guys, number one, we are told that the track is frictionless. Are you together? And another thing that we are told to ignore air resistance. So there are no non-conservative forces. So we can conclude that we can conclude that in the track we have an isolated system. Are you together? And in an isolated system, two things are conserved. Firstly, mechanical energy is conserved, and momentum and impulse is also conserved. Are you together? So in the first question, they want us to use energy. They want us to use principles of conservation of mechanical energy to calculate the speed of the 1.5 kg trolley at point P. Okay. By definition, guys, mechanical energy is just the sum of kinetic energy and potential energy of an object. So mechanical energy is conserved, which simply means the mechanical energy before should be equals to the mechanical energy after. Are you together? But mechanical energy is kinetic energy plus potential energy. Are you together? So this is initial kinetic energy and initial potential energy plus half mv squared final kinetic energy and final potential energy. Okay. The m represents the mass of the object. V represents the velocity of the object, and G represents the gravitational acceleration. H represents the height above the ground, or above the surface rather. Are you together? So initially, the 1.5 kg was at rest. Are you together? And it was released. It was not pushed. It was not propelled. So since it was at rest, it simply means its initial velocity was 0. Are you together? So if the initial velocity is 0, it simply means that kinetic energy is also 0. Are you together? So just going to add potential energy. That's 1.5 multiplied by 9,8, and the height above the ground is just 2.0 meters. Okay, and then at point P, we do have because now the trolley is moving. That simply means it has kinetic energy. Are you together? So we can simplify in the velocity there. 1/2 1,5 vf squared plus when the trolley is here, there is no vertical height or vertical distance rather between the trolley and the surface. So which simply means that potential energy is 0. If the height above the surface or above the ground is 0, the potential energy has to be 0 as well. So I'll just put a 0 there. Okay, and then on the right hand side, I simply have 1.5 multiplied by 9.8 multiplied by 2. I'll simply get 29.4. On the other side, 1.5 times 1/2. I'll simply get 0.75 VF squared. I'll obviously divide both sides by 0.75. 29.4 divided by 0.75. That's VF squared will be equals to 39.2. Obviously put square roots on both sides. Then the velocity will just be 6.26 meters per second. So the velocity of the block at position P is 6.26 meters per second. Are we together? At point P, the speed or the velocity of the block is 6.26 meters per second. Okay, and then now you're told that when the two trolleys collide, they stick together and continue moving in a constant velocity. Okay, the first question, they're telling us that the principle of conservation of linear momentum is given by the incomplete statement below. Rewrite the complete statement and fill the missing words or the phrase. In here, guys, you just need to state your conservation of linear momentum in words. It simply says that in an isolated system, the total linear momentum is conserved in both magnitude and direction. Are we together? Or others would prefer to say in a closed system, the total linear momentum is conserved in both magnitude and direction. Okay, then now let's go to 4.3. They want us to calculate the speed of the combined trolleys after the collision. We are still dealing with an isolated system, guys. So in an isolated system, guys, I told you that there are two things which are conserved. Mechanical energy is conserved. Momentum is the total linear momentum is also conserved as well. Are we together? So we can simply say that the sum of the momentas before collision is equal to the sum of the momentas after collision. Are we together? Or rather, let me write here on top here, because there is a bit of space. Sum of the momentas before collision is equal to the sum of the momentas after collision, right? If the 1.5 trolley, we can call it a trolley R, and then the other one trolley S. We can simply say that momentum of trolley R, remember that momentum is the product of mass and velocity, right? The mass of trolley R multiplied by the velocity of trolley R initial plus the mass of trolley S multiplied by the velocity of trolley S initial. This is equals to, remember that after collision they move as one unit because they are combined. So just going to add their masses, mass of trolley R plus that of trolley S multiplied by their velocity when they move as a unit. We are basically looking for this guy over here. Okay, I know that the mass is 1.5 kilograms and the velocity we got 6.26. The 2 kg trolley, the trolley S was stationary, which simply means that its velocity was 0. When the velocity is 0, momentum is also 0. When the velocity is 0, momentum is also 0. Okay, and then when they are combined, just 1.5 plus 2 multiplied by VF. 1.5 multiplied by 6.26, what do we get? On the right hand side, you'll simply have 9.39 being equals to 3.5 VF. So therefore the combined velocity will be 9.39 divided by 3.5. I will simply get the velocity of 2.68 meters per second. This will be their combined velocity after collision, right? Okay, so now on the fourth question, they want us to calculate the distance traveled by the combined trolleys in 3 seconds after the collision. In 3 seconds after the collision, right? There's a formula that says delta x is equal to vi delta t plus 1 over 2a delta t squared. But guys, remember that when the trolleys collide, they continue moving at a constant velocity. When the two trolleys collide, they stick together and continue moving with constant velocity. Constant velocity, guys, simply means that acceleration is 0. Constant velocity also means that F net is 0. Constant velocity also means that work net is 0. And constant velocity also means that there is no change in kinetic energy. So in this case, I can simply find the distance traveled because I do know the velocity. That's 2.68 meters per second. The time is just 3 seconds, plus 1 over 2 multiplied by 0 and then multiplied by 3 squared. So I can simply find the distance. 2.68 multiplied by 3. You'll simply find that after 8 seconds, the combined trolleys would have traveled a horizontal distance of 8.04 meters. That's how, guys, we would have tackled the question over there. And I really hope that, guys, the video helped you. Just stay tuned, guys, and please note that the other videos are on their way. Don't forget to like, share to your peers, comment, ask questions if you have them, and don't forget to subscribe, guys. Thank you very much.